The next thing we're going to look at is some very particular graphs in 2 dimensions and 3 dimensions. So what we're going to do is we're going to pick a function. We're going to pick a very simple 2D function. So how about y equals 3? That's just a constant line. It goes right through here where y is 1, 2, 3. So that includes all of the points where the y-coordinate is 3. And so the question is, what's that going to look like in 3D? Oops, I'm labeling my axes in a way that is different from the standard. So standard has the x-axis coming towards you, y-axis going to the right, z-axis going up. You can do it differently, but this is the way that almost everybody does it. So that's the most consistent thing to do. All right, let's go over here to my 3D GeoGebra, and we're going to graph that line, that equation. So first of all, I'm going to turn this around, and we're going to start just by looking at the XY version. So I'm going to turn this so that you can't see the z-axis. It's just pointing straight at you. And then we're going to graph the line y equals -3. Go. There's my line, y equals -3. Okay, so that's my line. It's down there, parallel to the x-axis. I'm not very good at turning this the way I want to. Never mind, let's twist it around and make it look 3D. So here we go. You can probably tell that this is turning into a whole plane. Oh my goodness. Okay, I'm going to turn this around so that x and y and z are going in the direction we expect. And so you should see that this plane goes through this point y equals -3. And all the points on this plane are the ones with different x-coordinates and different z-coordinates, but the y-coordinate is always -3. So that y equals -3 that gets graphed as a line in 2 dimensions gets graphed as a plane in 3 dimensions. 1, 2, -3. So if I was going to try and draw it on paper, it would look kind of like this. It's impossible to do really good 3D drawings on paper, I'm afraid. All right, let's change this up. Let's change this y equals 3 to a different equation. So over here in GeoGebra, I'm going to change the equation of that line. Let's make it y equals x. How about if we put an x plus 1? Oh, yeah, there we go. X plus 1. That looks good. So there is a line in the xy plane. And if you think about it, what's going to happen when I look at this in 3 dimensions? Well, I'm going to be allowed all the same x and y coordinates, but then this doesn't say anything at all about z, so I can have any z coordinate I want. So it's going to go straight up and down from that line. And because I have a cool program, I can move it around so you can kind of see the 3D-ness. So there you go. It's got that line in it. A thing I can do here is I can show where the XY plane is, so you can see where that intersects the XY plane in a line, and it's going straight up and down from that line, and so I have a plane. You can actually do something a lot like this with any equation. So if instead of having just an equation of a line, if I had a parabola, y equals x squared, then that would turn into, that would be a parabola when you looked at it in the xy plane. I'm not quite sure why it's not showing up. There. I hope you can see that now that I've tipped it. So you can see that I've got that parabola. Let's show the plane. There we go. So you can see it's intersecting in that parabola, and then it goes straight up and down from the parabola. So if you come up with an equation that would be graphed as something in the xy plane, you can turn that into a 3D graph just by going straight up and down.